For folks who, there was some like setup, but I think for ease of use across most people, raise your hand if you have Anaconda or another like distribution installed. Who doesn't? Raise your hand if you don't. All right, so for the folks who don't, I would actually recommend Anaconda. The perils of live Googling. If you just type Anaconda Python, this is continuums. If you do download Anaconda, that should get you set up with 90% of the libraries. The thing that is not in Anaconda that we're going to be using today is Luigi, and we can just pip install Luigi. So if you have Anaconda installed and kind of base Python, just pip install Luigi, and that should be the only new thing that you'll need outside of the distribution. Here I already have it, so it all worked well. And every other library is usually very easily pip installable. So if you do encounter something that doesn't happen to be in your distribution that is in the exercise files, just pip install it, and should be pretty seamless. So again, either clone this repo, clone it here, or just download the zip. And it's about like 10 megabytes, so it might take a second or two. If this doesn't work, if the Wi-Fi seems pretty wonderful here, but if it doesn't, I have USBs up front, so that's kind of last resort, USB it. But without further ado, we can jump in to today's workshop. So who here would consider themselves a data scientist? Raise your hand. Who here has ever been a professional software engineer? Who here considers themselves a data engineer? And who here has used Luigi or another workflow manager before? So people often use Uzi, Azkaban, there's Drake. Anyone use any tools that I just mentioned? Luigi? All right, perfect. It seems like everyone's in the right place then. So this is going to be how do we architect a data pipeline, or basically a series of stages of operations and code will run to build a machine learning model and get it into production. So our end goal is train a machine learning model, get it into production on some API server that we can ping as new data comes in. And we're going to see how Luigi can help us do that. So for folks who don't know me, I'm Jonathan. I actually did a similar presentation at one of the first PyDatas I went to, but it was much smaller scale and a different scope. So it's exciting to get invited back to this PyData almost a year later and kind of have this new revamped data engineering workshop. I am the VP of Academic Excellence at Galvanize, which is a really long title, which means I just build curriculum, work with instructors, and manage a lot of our immersive training programs. And for folks who don't know about Galvanize, it is a member and student community for education and entrepreneurship. Raise your hand if you've heard of Galvanize before. Awesome. So very excitingly, Galvanize just opened up a Seattle campus. So I'm excited to get excuses to travel up here. So we have a campus that just opened up in Pioneer Square, but I'm headquartered out of San Francisco, where I founded Zipfian Academy, which was a 12-week immersive data science bootcamp. So raise your hand if you've heard of Zipfian Academy. All right, cool. So we were acquired last year by Galvanize, and now we're running a bunch of workshops, trainings, full-time in-person immersive workshops targeted at data science, and in about 2 months, we're going to have a full-time immersive data engineering workshop. So exciting things on the horizon, but what are we doing today? This is typically when people ask me about what's the difference between data science and data engineering. I thought it's all just the same. This is typically the stages that I talk about with data science. So we have some function of preparing some data set that we have, whether we downloaded it or whether we got it from some API. Usually when we're trying to evaluate a model, we do cross-validation, where we need to split our data into training, test set, eventually we evaluate it. And this is, I almost say this is like the Kaggle model of data science. And this is, how do we build the best possible model we can? And it's great. It's a kind of endeavor in and of itself, getting very good at building machine learning algorithms and models. But oftentimes, kind of one of the harsh realities, you get out there in the world, many more boxes come up there. This is what I consider data engineering. All the boxes that are new. So we basically have raw data coming in. We have to transform it. We have to vectorize it. We have to featurize it. At the bottom, the red boxes correspond to what I like to think of production. So usually, you got to get your model off of your laptop. You can't just run scikit-learn on your laptop and say, hey, manager, done, ROC curve off the charts, area in the curve, 0.99, going home. And we're going to focus on the red squares today. So not the easiest thing to solve, but we have the wealth of Python and its scientific libraries to help us out. So this is kind of my linear model, and each of these is something that we're gonna tackle with one part of the exercise today. So we have at the start, kind of how do we get our data, how do we store our data, how do we parse, transform, vectorize it, we get a model, and we kind of expose it to the world. So most of what we're gonna be doing is on the right side here, where I say locally. At scale is kind of distributed computing when you want to do these things at large scale. But we're going to be focusing on working with scikit-learn, NumPy, and Flask to get this out there as a web service. And where does Luigi fit into all of this? So for folks who haven't heard of Luigi, I say it's the pipes. It's the glue that connects all of these things together. And it's a project that came out of Spotify to help them manage thousands of Hadoop jobs that they have to run every day on a schedule. So why pipelines? I always say kind of remember where your data came from and what you've done to it. So the idea of a pipeline, the idea of using this tool like Luigi is going to help us know where we got our data, what we did to it, and how to get back to either of those stages here. And why Luigi over something like make? Who here has used just make, like Unix make? So it does a lot. There's a lot it can do. You can make it work for a lot of similar kind of projects as Luigi could use. But one of the key things, I think, why I really gravitate towards Luigi, besides it being in Python and somewhat easy to use, is this idea of idempotence. So all this means is you can run a function code as many times as you want, and things are not going to have any side effects. So it's not going to be different the third time you run it from the first time you run it. We have the idea of checkpointing. So this is one of the things that Luigi was really built for, is I'm running 1,000 Hadoop jobs. Job 3 takes a day, and if it fails, it kind of blocks everything down the line. But if we do get past that very expensive, long-running process, if something further down fails, we don't want to have to go all the way back to the beginning. So this idea of checkpointing is go back only as far as things have failed. And Luigi, again, Spotify, huge kind of Hadoop and MapReduce shop. So Luigi has native MapReduce and HDFS support built in, which makes it very easy to either suck in info from a lot of different sources like Postgres, Hadoop, flat files, and then export it to all of these sources as well. And also sends emails to you when things fail. So never underestimate the importance of niceties like that. Here I kind of, same diagram, but the green is Luigi. So it's the pipes that connects each of these stages together. Anyone have any just high-level questions before we jump into code about Luigi, the purpose it serves, and what it's going to help us do here? Everyone feels the need for Luigi? Awesome. So that's the end of the slideshow that I'm going to get into. The core of Luigi is basically a bunch of classes, scripts, and functions that we're going to run. And so before we dive into things, I just wanted to kind of explain some of the kind of main components that Luigi gives us, the main knobs that we can turn and tune here. So this, I think I ended up getting in the repo. Yeah, so this is the example Luigi.py file. And this is the simplest kind of atomic unit that we're going to get in Luigi. So Luigi is built on this idea of tasks, and each task you can think of as one of those little boxes I showed before. So this task is basically reading in some data from some streams. This data could be something that creates a bag of words for some text model. This could be a task that trains a model. This could be any arbitrary Python code that we want to run. And Luigi gives us this kind of structure and framework in which to run them. So this is going to help us kind of manage a bunch of these dependencies here. And for an idea of dependencies, you can imagine you have some data source, you have some other task that trains a machine learning model, and the machine learning model depends on the data. So you end up getting this dependency graph. And the way that you kind of tell Luigi what you want to architect in this graph of dependencies comes from these three main functions here. So there's requires, which, can folks see, raise your hand if you can't see well enough the text. All right. So there's three functions that every Luigi task needs to define. Here we have requires, we have output, and we have run. So requires you can think of as the input for any Luigi task. So this is what am I gonna need to actually run the code that's contained in this task. The output defines where is the result of running this code gonna go. And the output of a previous task can be the requires of a task farther down the line. So requires and output go hand in hand, where you can basically chain together things. And then this wouldn't be very useful unless we can actually do something with this. So the third component is this run here. So run is basically, what am I going to do with the data that I'm getting through here? And we'll see kind of throughout here, there's going to be another kind of some other parameters and things we can tune. But these are the three main components: requires, output, and run for a single task unit that we're going to compose into this larger chain. Any questions on this here?
In the requires section, how do we specify the data that we care about rather than just the task? For example, let's say a task runs every 3 hours, and then there's a subsequent task that's dependent on a particular data of that task. How do I specify which data of the upstream task I'm dependent on?
Yeah. So that's kind of a common use case where if you imagine like clickstream data, you want to say this depends on the last week of our data. We'll see we can do that with parameters. So the other thing that Luigi has a lot of support for is date ranges. So usually Python can get kind of grumpy when you deal with dates a lot. Luigi makes it very easy to say, get this week interval, this day interval, this month interval, and run it on this repeating schedule. So we'll see how we can get into that. And that's partially where this date parameter comes in. All right, so let's get into the code. So this is gonna be a series of, there's actually many more people here than I anticipated. So it was gonna be kind of, I show you something, you work through something, I can come around and help. I think there's vastly more people for me to be able to come around and help. So it's gonna be majority kind of live coding, interactively going through this. And going through just what's in the repo. So ML pipeline is basically gonna be our solution. So the ML pipeline file is where we're trying to get to. And we're going to do this kind of having you all code along with me. There's a few other examples in here. And we can actually start with exercise.py. So there's a lot in here. Don't be afraid. One of the kind of things I was grappling with making this workshop is Luigi is the glue, but there's a lot of kind of prior knowledge you need to know about what's actually happening in each task. So this basically runs a pipeline to train a naive Bayes model with scikit-learn and then deploy it to a web service with Flask. So not everyone might know about all those things. So all of the run code I've essentially given you in this file. So if you don't know or aren't familiar with scikit-learn, Flask, NumPy, all these libraries, don't worry. The workshop is going to focus on the connecting glue. So the main things we're going to work with here in the exercise are the output, the requires, and the parameters to kind of architect this together. But if you do have any questions on the code that actually does the machine learning and any of the training, the evaluation, definitely throw a hand up or come and grab me after, and I'm happy to explain that more. The most basic task here is what we're going to start with, and this is just our input. So the machine learning pipeline we're going to build is actually, I'll show the result of it. So this is a really awesome library that I'm going to use to kind of show the results. So this is tangential to all of the pipelining, but this is a library that Stripe open sourced called Top Model. And it essentially gives us a way to get all of our important cross-validation metrics for any machine learning model, and it presents them in this nice interface. So this is going to be, as we go through this, kind of our compass to see what's happening with our model here. So it gives us the basic curves, precision recall, the ROC curve, a few of these others that are less common, showing you the threshold, marginal precision, and then the distribution of our classes. So we're dealing with a subset of the 20 news groups data set. We're trying to classify 2 of these kind of comment threads. The distribution here we can see is on the right, these are blue. On the left, these are the purple class. There's some separation. So we're going to try to predict blue or purple of each of these new documents that we're sending and build each of the stages of how to get here along the way. So this is kind of where we're trying to get. We're trying to get some machine learning model. This ROC curve is flipped. There's a few little configurations that, depending on how you determine positive and negative classes, sometimes this top model inverts this. But this is actually a pretty good classifier, inverted. And we're trying to get to some classifier that can determine which of these news groups are new data, our new text coming in is. And there's a few kind of stages that we need to actually get here. And the first of which is get our data. So how are we going to get our data to make this classification? In here, we have this task of input text. And in here, you see the new thing that came in from kind of the example Luigi file is this idea of a parameter here. So this says file name equals luigi.parameter. And this is going to be a way for us to specify on the command line where we either want to input our files or where potentially to export them in another task. So the key thing to note about this task is the class that we're actually inheriting from is a Luigi external task. So there's a lot of common paradigms when you are building these pipelines. One of them is, how do I start? So you need to know kind of what the first step of the pipeline is, and potentially the last step of the pipeline are going to be different than everything in between. So in here, if we use an external task, it lets Luigi know we don't have any dependencies in the pipeline before this. So external tasks are always the first thing that potentially get run. And in here, there's only output. So again, this is a unique task because it doesn't have any requires. So this task doesn't depend on anything. And it doesn't actually have any run. So nothing logic-wise happens in this task. It's just a way to start from somewhere to then build stages behind it. And in here, the code I have is a little complex, but it basically just gets us the directory that we're currently in, and it appends this file name parameter to the end of it. So key things with Luigi, it has a lot of quirks. One of them is the way it deals with kind of state in the program and how and what scope variables are in. So every parameter you define as one of these class variables here, and it comes in any of the methods attached to self. So self is this task that we're running. We say self.filename, get me this parameter, and return all of the files that are in this directory here. So this is starting off. I'll show you. We have this directory text here, a bunch of articles, and And we want to be able to suck all of these articles in some kind of smart way, process them into some matrix-like vector representation, and then train our model here. The first of kind of the challenges to all of you in the exercise, how are we going to create these two more parameters here? So we had our input parameter here, which is the file name. And I'll do a quick run through of how we actually get that parameter in. So Luigi, kind of in contrast to probably many of the other workshops today, it's all in files and not IPython notebooks, and it's all run through the command line here. So Luigi, this kind of think of it as this configuration process that we have to kick off. And the way to specify it is on the command line with Python, and this is going to be a good test to see if things work with the libraries that, that you have on your computer, and if you need to install anything else. So we start with Python ml-pipeline, which is the file name. So all of our pipeline is stored, actually, let's do exercise. So exercise.py is where is the code that defines our flow. The other nice thing about Luigi, similar to make, is that we can specify which stage we want to run, what parameters we want to run for that stage, and any other configuration right on the command line here. So let's actually just see what running the input text class is going to do for us. So in the exercise.py file, run the input text stage, and any parameters you specify with 2 dashes on the command line by the name that they are given. So this is called file name. I think I forgot to. All right, so I'm gonna cheat here and run it from the solution. So here, running it from the solution, input text with file name as our parameter. It says no task, no task input text. So this is letting us know that input text itself has nothing to do, nothing to run. And let's go and see the second stage to build the simplest pipeline we can to actually run something that's non-trivial. So the second step of how do we build this machine learning pipeline is to go from text to vectors or matrices. In here, we'll come back to these parameters, but if we run this again from the solution, so what are we trying to do with vectorize? So in here, we're running a vectorized task that has some parameters for the input directory. And in here, we're working off of the text directory. And if we run this, what is it telling us? point of note. So it turns all underscores into dashes for its parameters. So here we run it. We can see here it is telling me that it's scheduling the tasks, but that there's nothing to run. Can anyone think of why there's nothing to run for this vectorize, given that it's correct? So I'm running off the solution. I'm trying to vectorize all this text, and Luigi's telling me you can't do this, or I have nothing to do. In the back?
The first step isn't yet.
That's a good observation, but Luigi can handle any steps that aren't complete. So Luigi should run any steps that aren't complete for us if anything down the line depends on them. I mentioned it in the beginning presentation. So what does Luigi do for us? What magic does it give us? Checkpointing. So I already ran this before, actually, to test it. So it's saying, Luigi's saying, you already vectorized all your data. I'm not going to repeat that vectorization process. So I actually just blew away all those files. And we can see here, the output looks very different. So the vectorization in this case actually ran all of these input text tasks with all of these articles here. So this is kind of the first simplest one-stage pipeline that deals with, in this case, it's actually around 1,000, a little bit more, input texts. So notice each file gets its own task here. It does some processing here. It says there's a pending task, scheduling things with these workers. I'm running vectorize with these parameters, input directory text, evaluate false. So this is a parameter that we'll get to down the line a little bit. And then it asks for more work. There's no more work to be done, and it finishes. So here we can see it didn't throw any errors. We successfully got through all of our input data. And trust me that we vectorized it. And if we go back to our code, the output of this is actually going to be in a bunch of pickle files. So this kind of brings us to the second main point I want to hit on with Luigi, is that the hard work of Luigi doesn't come from the code to be run or the logic to be had, which can be like very frustrating for people. It comes from majority serialization and deserialization of inputs to outputs throughout the chain. So this isn't really a challenging logic task. It's much more challenging from an engineering perspective. So in here, whenever we have a task, my usual first step is, what do I get into this given function, this task, this class, and what do I want to get out? So I define the two endpoints kind of a priori and try to bring them to the middle. Just like with our pipeline, we said, where are we starting? A bunch of text files in this text directory, and where are we getting? Some trained model that has some, hopefully good, cross-validation metrics.
I have a question. So, excuse me, when I tried to run it, it had some connections to localhost, so I Googled, and something about a scheduler running. Do you already have a scheduler running?
I do. This is as good a time as any to get to the scheduler. For folks who are running this and haven't started the scheduler, there is another parameter you can give it where you say local scheduler. So in here, we say run it on text and use the local scheduler. So this basically does a little internal scheduler from something that's not really production ready, but helps us do things very interactively. So if we run local scheduler, this is going to say nothing to be done. But most of the time, I I would recommend using the Luigi central scheduler. And this is the kind of second or third, I'm losing track of points I've made, but let's say third thing that Luigi gives us. So who here has ever done like a lot of web scraping before? And have you ever done it in a way where you like every week want to get new articles or every day want to get new articles? Ever? All right, so this is kind of somewhat common data acquisition pattern is you want to run these things repeatedly, and you don't want to have to wake up at 5 in the morning and like go to your terminal and like type a command in. So Luigi gives us this centralized server that just runs in the background, and we can throw jobs at it. And we can say, Luigi, you're always listening. I'm going to throw a job at you to say, scrape some new web pages. And it does this with its centralized scheduler here. So it's run through Luigi D. So here it's actually telling me I already have one running. Let's see, where is it at? Anyways, I think it's lost in a bunch of my tabs. But that is all right. To run it on your computer, it's probably not going to throw that error. But you should run it Luigi D, and it should work. If it doesn't, or if you want to run it in the background, you can do -- background. And this sets up a server that is going to be listening for us to submit tasks to. And what it gives us is this heads-up display where we can actually look at pending tasks that are to be run, current state of tasks. So not only does this help us manage these dependency chains, but it actually lets us see the intermediate kind of progress of these. Let's see. So if we go here, it gives us this really nice graph of the current state of each of our tasks. And something that gets a little bit awkward is that the first task usually is your data input. Usually you have a lot of files. And on here, it actually draws each of those as its own task. So here, there's just a bunch of input text. There's this little box at the top. You can unclick Show Upstream Dependencies. And in here, we can see vectorize. We hover, we can see the parameters that we ran this with. And it's green, yellow, blue, or red, depending on the current status of it. So again, this is just one, nothing too interesting. It runs very quickly, so it immediately finished, and it finished correctly. But this is the kind of second or third advantage Luigi gives us over something like Make, is that we can diagnose where things break. So oftentimes, debugging is the hardest process, and better tools like this to help you debug are going to go a long way. Did folks run this first stage, and did it work? If folks want to try running this, try running it just off the ml-pipeline.py file for now. And then we can get the exercise py file kind of equivalent, and then the exercise py will work. On a Mac, it's Command K. On Windows, clear, yes, yes. So there's a few directories in here, and let me just look where I outputted it. So this is also a good chance to look at the output. So in here, I output a bunch of pickle files to the models folder. So if you want to just kill everything in the models folder, just rm models/star. That should clear everything out. And then if you run this, it should stream a bunch of stuff down. And then if you look at the models folder, we can see now we have some labels, we have some pickle files, and when we run the pipeline again, it says you already have those output files, nothing more to be done.
And so when I run mine, it looks like it ends with a post to port 8081, and it stops there. Is there another process that runs on 8081?
There is, but for now, we can just comment these lines out. Yeah, so, oh. Yeah, so in the vectorized run, the last two lines actually make a post request here. You can comment them out. They're going to be for when we actually want to deploy this model. So if you comment out these, there's a line that has files, dictionary with file data, and then requests that makes a post. This is going to be when we do have our API server set up, a way to ship either our, in this case, our vectorizer to it, or our completed model so that we can run things external to our laptop. Thumbs up if you got it. All right. The thumbs down, what error is it throwing you?
Failed vectorize file worker.py line 137 connection error, connection reported, error 61.
All right, you might have to do it with the local scheduler. Try with -- local scheduler. Yeah, so you also might need to comment out the post to port 8081 on our local host.
So in terms of just running, would I be, say I want to manipulate data on a cluster, I want to start the cluster, would I run Luigi and everything on the cluster, or would I run it on a sync machine and make one of my tasks to start my cluster?
Yeah, so in that case, if usually you'd have a cluster running with all of what's going to be doing the processing on it already. So Luigi doesn't necessarily do the processing. It's just a way to kind of kick off processing. And let's see if this is it. Yeah, so this is from the Luigi docs, kind of the high level of how it works. So usually your central scheduler, your central planner is on either it's on your cluster on like a master or it's somewhere. The client you can actually just run from your laptop. That Python mlpipeline.py is just a client command. So if I do have this massive like 30 node Hadoop cluster that I want to run stuff on, I don't have to like SSH in. I can just use the central scheduler and kick off a job from my laptop. And the central scheduler is actually what's going to ship off these little units of work. So each of these is a task, essentially, to either a machine or a process or whatever your unit of work is. So just bringing back to kind of, again, the high level of where we are, where we're going. So this is the kind of, it's not, the run is not simple, but everything else around this task is kind of the simplest unit of, we have one input directory and we have some outputs. So the vectorized task is going to be interesting because it's going to be our chance here where we can see how to create parameters. So in the first task, we had a parameter that was file name. And file name was something that we specified on our command line to tell it which file belongs to that task. But now we have to do a little bit more complicated work. And again, we're going to specify this parameter input dir for the directory of all of our text files. And Luigi is nice because it actually has some loose idea of a type system. So all of the parameters can potentially have some more complex type than just parameter. So parameter basically is like a string. So whatever you put on the command line, it just transfers that as a string into our task. But we have this ability in Luigi to specify more interesting types and also default values. So this gives us a lot of functionality that some libraries give you if you want to set options on like a command line program that you're running. So in here, the next parameter we're going to set here, so this is evaluate, and it's going to let us know, are we running cross-validation, are we doing a test train split, or are we just running through the pipeline with all of our data here? And the reason I want to put it up here in vectorize is because we're going to first have to determine these splits before we run our vectorizers so we don't overfit on our data when we're training. But the other unique thing here is that the bool parameter, as opposed to the others, doesn't explicitly need to be set. So this is something that, again, the type of parameter makes a difference. If you remember when we ran this here, nowhere on this command in vectorize did we say evaluate true or evaluate false. So this is one of the nice things that Luigi gives us, is for Boolean parameters, we can just specify whether or not it exists. So dash dash evaluate is going to say the evaluate flag is set to true. They've specified it. If not, run with the default value. So if you don't have dash dash evaluate, it says default false. If you do, so interesting thing about this task, when I added dash dash evaluate, it reran all of my tasks. I just showed you, I already processed this, I vectorized it. We should have been good. Why did Luigi rerun all of this vectorization on all of these files when I specified dash dash evaluate? So key point about Luigi, the definition of a task is not only the class, it's not only the file you're running, it's the parameters you give it. So this is going to give us a lot of flexibility in the next, the next stage of the pipeline when we want to train a lot of models or a few models with a lot of different parameters. So this is going to let us very quickly and iteratively cross-validate our model across hundreds of values of some parameter without having to rerun every single stage, without having to go back and process our text.
Is the state information stored by the scheduler?
So the scheduler stores it and also looks at the output. So the scheduler does some weird caching stuff that usually you don't have to worry about. But in a task definition here, whatever you, so I guess we'll go to that now. Whatever you return from your output is what defines done. So in your output, you say, what does it mean for task vectorized to be done, to be complete? Well, it depends on all of these files here. So let's see here. So the second list of to-dos I wanna get at is how do we define output targets and what does it mean? So this task is unique in that it has multiple outputs that we want. So if we think of this dependency graph, we have multiple inputs coming in and we have multiple outputs going out. And one of the conventions of Luigi, they actually, a lot of the core devs suggest that you should really only output one thing from each task. So you should modularize it so that each task only outputs one output. For the sake of this workshop, for the demo, for a little bit easier encapsulation, I'm actually exporting 5 files from this. And the reason I have to export 5 files is to remember how I've transformed these things to pass down further in my pipeline. So for folks who have, raise your hand if you've done text processing before with Python. So good kind of sampling across the room. But if you haven't, one of the easiest ways to do a lot of text processing with Python is to use scikit-learn vectorizers. And what vectorizers do, here we can say I define it. This one does TF-IDF, but you can also do basic word counts. They have some internal state that defines some idea of vocabulary. So when you're processing text and you turn a paragraph of words into a matrix of zeros, ones, and counts, you need to know what each column of that matrix corresponds to. So in this bag of words model, maybe column 1 is going to be all of the counts in all of these documents of A. And then column 2 is going to be all of the counts of an. And column 3 might be the. Column 4 might be basketball. Column 5 might be dog. So we have to have a way to go back to what the actual text was. So in here, we run this TF-IDF vectorizer here on all of our input words. But when we go and predict with the model we make from this, we need to make sure that we transform it in the same way. So however we transformed our data that we trained our model on, we have to be able to transform any new data when we make a prediction. And to give that down the line, we pass this as an output. So we actually pass the vectorizer as an output. We pass the labels of our data as an output. We pass the actual vectorized matrix as an output. And in this case, if we are evaluating, we pass these 2 different splits. So we pass the testing data set that we're going to evaluate our model with and the testing labels that we've separated from our initial data here. And one thing to note about outputs is that, and most of the Luigi methods actually work this way, so output and requires, is that you can give it a list or list-like thing of Luigi objects or classes. And here I'm just passing it as a list, but this works with any enumerable-like thing in Python. So we can actually use a generator or some other iterable data structure to pass multiple outputs. So in here, we're kind of saving everything to the end and then just outputting this list. But we could throw in kind of additional targets if we want with yield potentially, or another data structure that we're using to store all of these. And each one of these is going to define this uniqueness of completion. So in here, Luigi needs to see that our models folder has corpus.pickle, vectorizer.pickle, labels.csv, and then these two additional targets that we're going to define here. And just like the parameters has a bunch of different kind of types, the targets have a bunch of different types. And this is another strength of Luigi. I think of it as this many-to-many coordinator. So we can have many different types of inputs from a database, Hadoop, flat files, anything, and we can have many different types of outputs. So maybe I want to put this to Hadoop. So I say, this is a Luigi HDFS target. So this is going to a different file system than where it came from, and Luigi's going to serialize and coordinate all of that data transfer. But for this part of the workshop, kind of keeping it simple, we're just passing it to another local file. And in here, we're passing this X test and we're passing this Y test. So these are individual pickle files that we've serialized in our run method. So show of hands, who here's used pickle before? All right, pickle, one of my favorite features of Python. Pickle's just a way to take a Python object and convert it into some binary representation that we can store in a file. So in here, we're going to models, and let's call it xtest.pickle. So this is all of our test data. And giving another, let's just say Y test for our labels here. So this defines our outputs. And if this evaluate flag is true, so if we specified evaluate, we're going to output our X test and our Y test as well. And then after all of this, we return from this output function the actual targets that we've collected here. Any questions on vectorize? There was a bunch of new things, mainly the inputs and the outputs. A whole lot of complex stuff in here that.
Where did the files get actually written to?
Yes. So the quirk of Luigi, it has quirks, but you get to learn to love them. You write out files just like any standard stream inside of your run method, and you have to close them. So you have to close your files for Luigi to be able to manage this dependency and completeness. So in here, we open a bunch of files, we do some pickle dumps, we do some writes, and then we close them. And the way to actually know what to open and close is in this self.output. So just like we had all of our parameters on the self object, so we have self.inputdir, we also get all of our inputs on self.inputs method call, and we also get all of our outputs. And again, there's magic, but there's not a ton of magic. So this just calls our input function, which actually aliases to requires. So whatever our requires function returns, and the return is actually very important, that's what we get from the call to self.inputs. inputs. And the same thing for the output. In here we have some function. We've defined it to, in this case, output a list of 3, and if we evaluate 5 different targets. So up here, when we actually want to output to the targets, so think of the target as this like abstract representation that Luigi does. We can just index into this list here by bracket notation, or we can iterate through all of our outputs, open each of these files, write all of our data, and then close at the end here.
Why self.inputs instead of self.requires?
So I believe they're going to return the same thing. I think they're identically aliased. Inputs might have been an older legacy, but yeah, they both return the same function.
Lines 61 and 62 will need to open and write the text to next string.
Mm-hmm.
Yeah, just real quick, it looks like the serialization and deserialization is a bit fragile because I think you give lots of tasks, you're going to be copying this code over and over again. Is there a way in Luigi to kind of have an object that defines how it's serialized and deserialized and kind of share that across all your tasks?
Yeah. So the nice thing about Luigi is that it doesn't really enforce a whole lot of constraints on you. So you can just define your own method or your own class that does that, and in here call it, let's say we have my serializer dot serialize, and then in here something like data. So Luigi is kind of just this infrastructure. The only kind of serialization specification it does, it just needs to know about these targets. So you can, again, extend this, and you can even define your own target if you want as a class, for maybe you have some weird, unique custom database that you want to write to. And then you can just import it like any other library, just use it in the pipeline. So the other point of how do we actually get data out of an individual task here? So we're actually going to need to write each of this X test and this Y test. So defining the output is kind of the first stage. Then actually creating the output is the second. So in here, we're going to do the same thing as we saw here with our opens. So let's call these XH for X handle, YH for Y handle. So these are going to be the file handles that correspond to outputs 3 and 4. We're going to open them for writing, and then we're actually going to let's serialize them with pickle. And then always remember to close.
Is there a reason you're not using the with construct on these? You still above the read things
What was that?
in. Is there a reason you're not using the with construct on these since you're using up above the read stuff in the inputs?
No. No big reason. The main reason here was just kind of to explicitly show that you need to close it. So if you do use with automatically closes files out. But usually in a Python program, you can get by even if you don't explicitly close when the program exits. But you definitely always need to close with whatever construct you want in Luigi for it to actually know that that task, that process has written something out.
Would it break if you appended or did a partial write before you're done with the file? You save some data in the file? What?
Saved it to the file and before the task ended.
Yeah, basically you only wrote like some of the data to the file. Would that confuse Luigi if there was a partially written file?
It shouldn't. So another pattern that I've used a lot is iterating through a bunch of inputs and then writing line by line, doing some other stuff, then writing more lines, doing some other stuff, then writing more lines. That's one way to get around this like multi-output file problem. So in here, I kind of split up all of these outputs and had it be this very atomic process of open, write, close, open, write, close. But maybe I just wanted to keep one thing open the whole time and then just keep writing.
How does it know you're done writing the file? Like the next task that's dependent on that file? How does it know all the data?
So you would, maybe I misunderstood the question. You would need to close it at somewhere at the end of the run.
Yeah, so you can't write and close it intermediate, like flush the buffer because that's too much data.
Within the task. I haven't run across it. There might be some way to do that. For like you're worrying about a lot of data that you're reading in, and like sequentially, maybe you're going over like 10 terabytes on your hard drive. Yeah, the other thing, I haven't tried this. You might be able to just open and then close and like flush the buffer. Anyone have any other questions on this task? This is kind of the task that has most of the basics of what you need to get through a pipeline with Luigi in. And again, just highlighting kind of what these components are. We have requires. So this is usually where I start. I say, what's my given task need to do? In this case, I'm vectorizing some data. Where do I get it from? I get it from this series of input text. What am I actually going to do to all of this data? I'm going to go through and I'm going to vectorize it with my scikit-learn tf-idf vectorizer. I'm going to output the relevant files and write them as pickles here, closing always, and then defining where these actually end up. In here, we have a bunch of these targets that are just files in my local file system, but these could be database instances, this could be Hadoop. And at the end, this task, it's going to look at each of these for doneness, completeness, correctness. Oh, question?
Just about requires up there. Can Luigi gracefully handle situations where C requires B, but if B is missing, it can depend on A instead?
I don't think it has any native support for that. You might have to code logic in. Most of the Luigi dependencies that you define, it treats somewhat as hard dependencies. But you might be able to program logic into the requires itself.
I have a question, maybe it's an aside, but if I wanted to run writing tests around this, like I want to be able to test my run function, so I would just do it like I would write any other Python test, try to instantiate this class and just test the run function.
Yeah, so this is that brings up a really good point of interesting use cases for Luigi. So if you want to make sure that your logic is sound and your inputs and outputs are, you can basically mock the run function, give it some stub data, and look at its outputs outside of like the framework of all of your data or your cluster or what have you. So let's say we're even doing something like a MapReduce job, and MapReduce has its mapper function, it has its reduce function. When you test it, you don't always want to like spin up a Hadoop cluster and like run all of your data through it. So you can use Luigi to basically stub out the mapper and the reducer, run it in the pipeline and test it locally. And then once it works for your example data, just transparently run it on a cluster. So this gets us a long way knowing about these three concepts, knowing about parameters as well, but it's not, this isn't really providing a whole lot more to us. If you write this in just a single Python file, all of the work we've done here is like 3 lines of Python. It's much easier to write and read and coordinate. So it always begs the question, like, why use this? Why use this tool? Is it something that we need to use? And what's a good advantage that this gives us over just writing in a single file? And the train classifier here, hopefully, is going to give us a glimpse into interesting kind of use case patterns of using Luigi. And in here, so the parameter, we're going to want to create a parameter for our naive Bayes for its hyperparameter. And for folks who aren't familiar with the naive Bayes algorithm, the one in scikit-learn can take a single hyperparameter that defines your regularization constant. So this is something that you a priori, before you run your model, before you train your model, say, this is a parameter to how I want my model to be built. And usually there's no hard, fast rule in what the best one is for a given algorithm. So you just have to test it over and over again. So to find out the optimal value for this parameter here, we're going to run through a ton of different parameters and see which one gives us the best output. And this is another common pattern of using Luigi, is if you do have a range of dates, if you have a range of parameters, if you have a bunch of minor tweaks, but most of the logic stays the same. So most of this code is going to stay the same regardless of whether I use a hyperparameter of 0.2 or 0.3 or 0.4 or 2. So in here, going to kind of, again, these loose types. In here, we're actually defining a float parameter. So Luigi reads this in from our command line, converts whatever that parameter is to a float. So we don't have to do type conversion on our end in our script. And this gives us some loose guarantees that you're actually using the right parameter. So if I try to call this with not a float, let's say default equals 1, it's gonna yell at me. So enforcing some rigidity, the requires is actually really simple. The only thing we need to do to train our model is make sure we've vectorized all of our data. The run, a new thing that we didn't really see before is that we actually have to deserialize in this method. So this is one of the cumbersome aspects of working in a framework like this, is to get this idea of idempotence and checkpointing and all these other things that are more like systems benefits of our pipeline, we have to go through some hurdles just in our programming. So every task is self-contained. It can run on this machine. It can run on another machine if I'm working on a cluster. And we have to be sure that everything within a task we can get back to that state, which is why we have to write all of our outputs to disk and read those in, even if the pipeline doesn't have any breaks. So even if vectorize, So even if in our vectorize here, it doesn't break, there's no real way to, let's say, store our model in memory and let Luigi know, hey, it's in memory, go to this address and like read in this Python object. We have to just do it through serialization and deserialization inside of our run. So vectorize, we know gives these outputs. So in here, we can just open these files. So we say go to input 1. So the input is whatever the vectorize returns as output. Deserialize these x and y for our test train split. Deserialize our vectorizer. Run, or rather create our naive Bayes with our lambda parameter. Do our fit, so fit our model. And then again, here's this pattern of open our output, write our trained model, and then close our file. So this run function, much simpler than what we saw with vectorize. So this is pretty self-contained. Kind of strangely, the only thing that we're doing that's not boilerplate is this fit. So all of this code is basically deserialization boilerplate. All of this code is serialization boilerplate. And this is the only like new code that we've gotten from running this task. But again, that's all right because this gives us a lot more kind of predictability in the pipeline as a whole.
The 0, 1, and 2 references there, the input, where is the ordering of those parameters coming from? Is that the output of the previous stage?
So the self.input, you can think of it as calling the output function of whatever you're requiring. So self.input says, what is my requires return? It returns vectorize. What does vectorize return as output? It returns this list of 5 things. And then in here, for our output, we're going to do the same. We're going to define a new target. We're going to return that target. And we're going to access this from the output that we're dumping here. So always remember, you always need to return from outputs and requires. You don't always need to return from run, but you always need to return from requires and output. And in here, we're going to just go into Luigi.local target. Let's define it to be in this models folder. The next pattern of things to do with Luigi is defining your names of your outputs as dependent on your parameters here. So again, the outputs are what are the uniqueness of completion. So if we run and train our model with different values of our lambda hyperparameter, we want to signal to Luigi that those are all very different models. So we can do that by saying each of these outputs to a pickle file that depends on this lambda parameter. And as long as that lambda parameter is the same, we're going to treat them as somewhat equivalent models here. And if we save this, let's see if the pipeline will run here. So let's first actually look at what we have in our models. So models here has our labels, it has our corpus, it has our vectorizer, it has our x and y pickles. So we have everything we need. Let's say we're going to evaluate this, use the local scheduler, Everything else is actually the same parameterize. And in here, we're running the train classifier with, let's say, a lambda of 0.5. So the other kind of cumbersome thing with Luigi is these parameters. Notice I'm not using input directory in my train classifier task, but a task down the line or up the line needs to use it. So I need to specify it on the command line when I run train classifier. So since the input needs, or the input dir kind of defines what I'm vectorizing, and vectorizer looks to those input text tasks, we have to specify our parameters basically whenever we run any downstream task so that they can bubble back up to any task that needs these parameters.
If you leave a map, will it remind you?
Yeah, so Luigi's actually very helpful with these things. So even if you misspell, let's say train classifier, it's going to say, hey, did you mean train classifier? And you're like, yes, Luigi, I did. You're the best. If you just run your pipeline without any commands, this actually gives you a very helpful help message that, oh, no, that doesn't. Let's see. -- help. So if you run your Luigi with -- help, it's going to tell you all sorts of interesting flags you can use, and it very powerfully, dynamically creates command line parameters and tells you what those are. So some of the magic of Luigi is, remember, nowhere in here did we say -- input - dir is a parameter that I can run in the command line. The only place that comes in is by this name. So it's the name of the variable that you're setting basically gets read in, converted to a command line parameter, and accessible through this list. So if we look down here, we can see each of the tasks has a parameter that it has read from what we defined. And there is a few extra ones. So these are ranges. So this is what I was mentioning before. If you do want to run it on a range of dates. And then each task has, let's say, the deploy models task has its namespaced parameters. So deploy models has an input dir, just as evaluate models has an input dir, just like vectorize has an input dir. So all of these just kind of cascade down throughout. And if we run our train classifier, let's say lambda of 0.8, input dir of text. Let's actually use the centralized scheduler. Let's see, what other parameters do we want to specify? Let's just go with that for now. And let's see if I can catch this. So these, unfortunately, are very fast tasks. But I want to show the status of the centralized scheduler. So if we look here, let's see if we can. Luigi, you're too fast. So pending tasks, train classifier, dependency graph. Oh. So here we can see we actually caught it. Vectorize is still running. Train classifier hasn't run. if we refresh the page, we can see they've both finished. So realistically, these aren't going to be tiny Python scripts that you run on your laptop. They're going to be large Hadoop jobs. They're going to be long-running processes. And this is going to be something that if you are doing some engineering, you come back to and you keep checking. So if you want to know, hey, like I came back from lunch, has my crazy large text processing job finished? Well, let me go to my heads-up display. Let me go to the dashboard and see. And if things go wrong, so this is, again, another thing that we can kind of force in here. So let's just throw some error in here. So just return some non-existent variable in our vectorize. It seems to have not broken. Yes. So if we go back here, we can look and see all of our input tasks, our data, the text files, no surprise, nothing broke. But our vectorize is showing red here. So vectorize is going to be the first thing that gets run when we rerun this. And train classifier is yellow. So this is still hasn't gotten a chance to run yet since vectorize has broken. So test or train classifier may or may not have errors in the code. We know for sure that vectorize has errors in the code, and this may work if we fix vectorize, or it might also be broken. So if we go back and I'm just going to remove the error. So we go back. We run our pipeline, we look at our status. It's currently running, so it's in the process of vectorizing, it's blue. We refresh again. Vectorize passed this time, so green lighted, and then train classifier gets green lighted as well. So this is kind of a somewhat simplistic version of how to use the heads-up display dashboard here. But you can imagine, let me try to go to the Luigi docs for their picture of what the Spotify one looks like. Yeah, so you can see here, this is their example of one of the pipelines that Spotify runs. So you can see here, this is very non-trivial. There's a bunch of users. They each have different, these are, I think, locations or songs. You basically have this spider web, and in here some are running, some are done, some haven't run, some might have errors. So when you do have something complex like this, Luigi is going to help you be a much faster developer engineer as you process these things. So we're kind of getting to the end of our time here. The last part of this whole process that I want to go into. So the evaluation here, there's not a whole lot of super cool, new, exciting things on the Luigi front for that task. The place where there is a lot of interesting, exciting things to get into is deploying the model. So I'm actually going to fast forward through the evaluate model and get straight to this deploy model. So let's say we have built this pipeline. We've gone through each of these stages. So we have a task for our input data. We have a task for our TF-IDF vectorizer. We have a task for training a model. Let's say we've already run our task that evaluates how well our model has done. We look at our top model here. We say, wow, performing great. Let's push this to production. Let's have this model run on all of the stream of user data that's coming through our app. In this example, I'm just going to go through a somewhat simplistic Flask app. So again, if you were doing this at a company in production, you're probably not going to be using Flask to expose this model. But this is kind of the simplest, non-trivial API for this model so that we can expose it. So one of the things that data engineers face a lot is how do we get, I say, model off your laptop? And Flask is going to be a way for us to get our model off of our laptop and have the ability to not only expose this to other people in our company and other data coming in, but very programmatically update it. So in here, for folks who aren't familiar with Flask, we've defined these routes. So this is a web server framework. So we define a bunch of these endpoints. So in a browser, if you go to, in this case, for the top model, it's localhost 9191/model/data and so forth. So in our Flask, we define a bunch of our own endpoints that we can run. So here we're saying /refresh. So whenever I hit localhost, in this case, let's say I'm running it on port 8081. So whenever I hit localhost port 8081 /refresh, that's actually going to update the model that's stored on this server here. So a somewhat hacky way to do this. Again, I don't recommend you doing this in reality at your company or in production. We're just going to store these instance parameters on our Flask app. So we say, create a new Flask app and initialize this model and this vectorizer objects to be none. So when the server starts, there's no model that's internal in this Flask app. And all of those places in the code where you saw /post were ways to send our data, our vectorizer, and our model to this Flask app here. So going to what refresh does, refresh basically sets the current model to whatever we send in this request. And you can imagine you train your model on, let's do this. So let's say we actually want to train our classifier on a lambda of 0.3 and a lambda of 0.9 and a lambda of 1. So I just created 3 more models. You can see it was fairly easy and effortless with Luigi. You just, again, have to specify different parameters. It treats it as a different task. If we look at our models folder here, we can see we have many more. So we have a pickle for each one of these parameters, our 0.3, our 0.8. So we have a bunch of these competing models. We use our top model to figure out which one's the best. And we decide we want to put alpha of 0.8 into our API. So we just need to hit refresh with our model. We need to hit vectorizer with whatever we used to actually vectorize that data so that we can transform it in the same way. Again, you always have to transform any new data that you're going to predict with in the same way that you've transformed your data when you actually trained your model. And then at the bottom here is a simple route that can accept new data. So once we set up this Flask app with all of our models, we can hit /predict, and it's going to give us a prediction of what it thinks this new data is. And how we get things into it from our pipeline. So bringing the pipeline out here. The first stage is make that post request with your vectorizer in the vectorizer run. The second step is make an equivalent post request in deploy models to actually send it to the server. And then you can imagine we also might want a predict task or something else to actually make predictions on this new model that we've updated here. So in our directory here, we're actually going to run our app.py. So that whole Flask app was just in this app.py folder. So if we say Python app.py, this actually is telling me that it's already running. So my app.py is already running. I can rerun my whole pipeline. So I'm just going to get rid of all of my models. I actually am going to run the deploy. So deploy models depends on train classifier depends on vectorizer depends on input data. And all we need is to know where it's getting input and what the lambda we want is. So again, we said lambda of 0.8 is the lambda that we want to go with. So let's deploy our naive Bayes model trained with a lambda of 0.8 to our Flask server. Let's run this. Let's go to Luigi. Let's see if I can see some interesting pending tasks, dependency graph. Hey, and it all did it before I could get to it. But anyways, so we vectorized, we've trained, then we've deployed. Notice this is kind of bottom up. So the earlier tasks are at the bottom of this, and then we go up. Deploy model worked. We got the green light. So now if we go to, let's actually just do this on the command line. So I'm just going to use curl here to send some data in. So let's say a new article, it only has hello world in it as its text. We want to know what category it is. So we go to localhost /predict. Port 8081. Internal error. Something in here seems to have broken. Let me just quickly put a debugger in. Just a shout out, if folks don't use debuggers, I highly recommend them. If there's nothing else you take out of this talk, IPython debugger, probably my most valuable tool. It's surprisingly not well known in the Python scientific community, but it lets us pause in any arbitrary place in our Python code. Let's see here. something is happening. I don't know if I will take the time to go through this, but trust me, this should be working if everything is set up right. Let me just try one last thing. Yeah. Oh. So here we have our debugger working. We can see here, right when the predict method got called, it stopped execution. So we can actually look at our request. We can do request.form here to actually see the data that got passed in here. So it's keyed at data. The value is hello world. If we do request form data, we're going to actually print that out. Let's see if we have vectorizer defined. Vectorizer does not seem to be defined. So somewhere along our pipeline, vectorizer did not get thrown up there. What was that?
It's vectorizer is defined and classifier that's never used.
Which line?
Line 109. Oh wait.
Yes, so let's try to just rerun the entire pipeline here. Let's force it to actually vectorize. So just reinforcing all of our vectorization, our training. We can see here, so again, looking at the output of our server, our vectorizer has been successfully uploaded, our model's been successfully uploaded, and now let's cross our fingers. Vectorizer is there. We got status code 200. Survey says hello world is of IBM PC hardware. So probably not what it is given such a short amount of text, but that's kind of the end-to-end pipeline of how do we go from a giant directory of text to naive Bayes TF-IDF model, deploying it to Flask that's running somewhere and getting the ability to actually ping it with new data and get some classifications on it. all of which was greatly assisted through the structure of Luigi, the visualizer to help debug where things went right and where things went wrong, and Stripe's top model that helps us evaluate how well our models actually performed. And in the ML pipeline, there is a bunch of other tasks that I didn't explicitly talk about. One of them is building a topic model. So you can imagine that we want to do some unsupervised learning in some stage of this pipeline. So being able to classify new articles is good, but maybe we want to actually inspect and see things that are happening with some potential topics that are happening. So we can just define a new task. We don't need to re-vectorize all of our data since we vectorized it for our naive Bayes model. And it's just as simple as creating a new task and throwing it in this pipeline. The point that I didn't actually talk about, probably the most important, you just have to kick off the whole pipeline with luigi.run at the bottom here. So if name is main, luigi.run, and this is going to allow us to programmatically call this or call it from the command line when we want to do kick off this whole pipeline. Folks have questions on this?
Can you run the workers on multiple machines? And then if you can you limit certain tasks to certain machines? With your hardware?
So you can definitely run the workers on other machines. I don't think Luigi would provide you anything to limit hardware for specific tasks internally. The very quick way of running things on more machines is there's this parameter called workers. So this specifies the parallelism of the tasks themselves. So this is saying I want 4 tasks to be able to run in parallel. Workers equals 4. Let's just workers equals 4. So this should actually be running 4 in parallel. It finished a little bit faster, but that's the built-in Luigi kind of parallelism that you can then configure with a bunch of other config files. So if you go to the Luigi docs, there's on the side here configuration, and you can see all sorts of parameters that you can specify in a config file. I don't think, you can do a lot, but I don't think you can say these tasks run on these given machines with this given.
You can't start up a worker and say you're only working on these 5 tasks. Can you give a list of tasks that you'll work on?
I've never gotten to that granularity of it. It might be something that's buried in this configuration and that you can kind of add on, extend to.
I saw that you had some pre-baked tasks for like outputting to like a Postgres database. Are there any pre-baked tasks for reading from a Postgres database as well?
Mm-hmm. Yeah, so all of the pre-baked, let's see, where is it? If you go to the Luigi GitHub, all of the pre-baked tasks most of them are contributed by the core devs or the community. If you go in to the Luigi folder, there is a contrib folder. So this is kind of the extensions to tasks. So let's say I am someone who's doing Spark work. I write up a task that basically in here inherits from task. It's just defined like we've defined everything in this workshop. And this is a way to have custom tasks that other people can use if they want to work with Spark, if you want to work with SQL, if you want to work with Postgres. But yeah, if you look through here, you kind of see all of the possible input-output options that are pre-baked.
Palladium is another pretty interesting project that kind of can, to some extent, from end to end, manage a lot of what we went through today. Have you used that, and what are your thoughts, strengths, weaknesses, as opposed to Luigi?
Yeah, I have not used it. Yeah, this is actually, what's it called?
Palladium? Palladium Git. So kind of purpose-built for sitting on top of like a relational database and then exposing a web service. But
Yeah, so this looks,
not quite as intricate what you can do with the pipelines. But
yeah, so this looks more like what we did with Flask. So I can kind of read through this if you want to send me a message after. But this, I believe from this quick look, looks like a way to create a web service from a model very easily, and not necessarily do everything that comes before exposing it as a web service.
So for repeating processes and training on new data, would you just set a cron job to rerun your Luigi pipeline every so
Mm-hmm. Yeah, so going back to, yeah, so the docs for Luigi are actually pretty great. The pattern for running repeating tasks is to set a cron job to whatever your command line command you want to run. So in your cron tab, you would just put this line of code, and it would say, I'm going to run this shell command every morning or every evening.
And if we were trying to like incrementally process logs, for instance, we would just code that feature into the inputs.
Mm-hmm. Yeah, so for like incremental processing of logs, you would put it as one of those date range parameters. Let's see if I can. So if you look at the help parameters, there's these range bases. Hourly, weekly, hours back. So you can get pretty granular in how you specify a range of inputs to go over.
When you have many tasks already on the fixed number of workers, how does Luigi select the tasks to run next?
I believe it's just the default's greedy, essentially. It doesn't do any smart management. So this isn't necessarily something you use in place of like a cluster manager. So something like Mesos manages a cluster, like Yarn manages a cluster and uses resources most efficiently. This is more analogous to like Make. It's like a way to encode dependencies in code and a way to schedule things. But the actual like execution, Luigi kind of says hands off, like I'll let whatever cluster I'm running on figure out how to optimally do that.
Depending on the ordering of the arguments for different stages of the pipeline, it seems like an area that could lead to some errors. Is there a way to use keywords or another mechanism to try to pull out arguments from different stages, or is it only using integer indexing?
For which part?
The 0, 1, and 2 references there when you're pulling stuff out of input and output, and then you have to remember that or look back at that to make sure that the 0, 1, and 2 in one stage is the same as the 0, 1, and 2 in another one, versus say using keyword arguments or some other sort of labeling mechanism not using one mono.
Yeah, I haven't tried it, but again, any of these outputs should work with anything that's like iterable. You might be able to just use a Python dictionary here and have it have those keywords. Yeah, again, the Luigi like core devs suggest that you should actually only have one. So like usually their suggestion is we're not gonna put a lot of functionality around that because there should only be one. But for this case, to keep it in something where I don't have like 100 tasks and all like confusingly talking to each other, I tried to compress things into smaller tasks or fewer larger tasks.
When you were uploading and it was failing, what would be the best way to kind of handle that? Like tell Luigi that this part failed and
with the deploying the model?
Yeah, deploying.
Yeah, so a lot of that comes in how you define success. So the ways that you can tell, or the ways that Luigi fails, is either like you put something in your code where you're just like, this is a variable that doesn't exist, or you make an error in the run method. The other way to encode it is with the outputs. So when you do deploy it, I didn't kind of put the safeguards in there, but I probably should have listened to the response back. So I should have said, I'm making a, where is it? I'm making a post request, but I'm not actually looking at the response that got sent back from the server. So realistically, I would say if response from the post is 200 success, then do something to indicate the output complete. So in here, I indicated output complete by just putting the pickle file in a separate deployed folder, so I know what models are deployed, which ones have I deployed. But if it would break on this post, maybe I would in here do something where I say, like, if response.code equals 200. So only trigger the output if the response code is 200 from the earlier post. And then as long as, or whenever this fails, response is going to be something like 500. The output is never going to get completed, and then Luigi's going to see that as something that's systematically failed until the request.post succeeds. Other questions? Awesome.
One more quick. Do you think Luigi is still, or have you used Luigi when in cases where you don't hold the Java? In other words, this seems like a really nice solution as long as everything you're doing is within Python, but if you want to actually interface with other languages, is Luigi a good framework for doing that?
Yeah, so it's pretty agnostic to whatever you're running. The pattern that I've seen when you're using a lot of different languages is you actually have all of those as things you would call as either sub-processes in Python. So Python, I'm pretty sure Spotify uses it for many, many more languages than Python. And you can do things where in a task, you can, I think there's even Mortar Data made a shell command task that lets you just run any arbitrary shell command to, let's say, kick off an R script or kick off a Java file. So this is just, again, the like connective fabric, and then you can have it connect to whatever you want. All right, last question.
Would you say you look a little bit like Luigi?
No, I like red more than I like green. But yeah, I'm going to be hanging around all day at the conference and would love to talk more if people have specific data engineering questions, Luigi questions. I could keep going on this, and I wish I could, but the next speaker is coming up. I will quickly flash my contact. So if you do have any other questions, I actually set up this Gitter chat room. It's basically like Slack through GitHub auth. I'll answer questions in there. Email me, Jonathan@Galvanize, or tweet at me @ClearSpandex. And yeah, thanks again for coming out. Hopefully you learned something. And I'll be milling about if folks have questions on data science, data engineering, or Luigi.